weeks, except the, what was that? Spring break. So, including spring break, 3 in a row, so we couldn't have a class. So, it looks like the first meeting on March. So, at first, I'd like to reschedule something. So, today we are going to, I'm not going to review the HBase, so you can study by yourself based on the lecture video that was recorded the last semester, but the HBase is not the major part of the big data solution. We are not going to use even the HBase as a solution of the big data problem. Instead, if you are interested in the HBase, so I'm going to offer the HBase the next semester for 2018. Including the MongoDB, Cassandra, and the other NoSQL databases. So at the time we can study more details about the NoSQL database, including HBase. And that is the first thing. The second, if you take a look at the schedule of the So we are now in the March 28th, so I'd like to have the start session the 2 weeks, this week and next week. So 2 weeks will be shrink to the 2 weeks, then the April 11th. So we will discuss about the BigQuery, the Google Cloud Platform solution, which is not mentioned here. But it may take the 1 or 2 weeks. I do not, I cannot decide, but anyway, if we have the time, so we will discuss about the data mining and other machine learning in big data. Probably that will be part of the BigQuery also. So we will, I will introduce the GCP solution for the big data. Then for the exercise lab, we missed the exercise lab from the here, right? The scoop and others. So we do not have enough time because of the missing the 2 weeks. So next week, Thursday, from 4:30, probably from 4:30 to 6 o'clock should be open because of the engineering 400. Okay, so only few classes are running. So at the time, we will have the exercise lab. We will announce I'm going to find the classroom. So we will announce where we are going to have the exercise lab. So it's not mandatory, but the strongly suggest to attend the additional class for the exercise lab. So we do not have the exercise lab in this classroom. So today we don't. Maybe next class, if we have a time, we will continue for the Spark. But first, I'd like to cover the topic by the lecture. Then if we have a time, we will have the exercise. But if we missed any of them, the next week, the Thursday, 4:30, probably if I cannot find a classroom, it will be the computer lab in South Shore. That will be the 24th. So in case we have more than 24 students to attend, you can bring the laptop, then you can practice by yourself. Practice with your laptop, we will try to find more chair. Okay. So that is the next 2 weeks Spark, and the next week we will have the additional exercise lab, and April 11th we will have the BigQuery on the GCP, and maybe continue. Otherwise, we will have this one. Then the fifth and final week, so we will have the project demo, and including the presentation of your final product. Then the last week during the final exam week, we will have the final exam. Instead, I'm going to cancel the midterm exam, so I don't think we have a time to finish. So instead, we are going to have the final exam. That's only that can be the midterm, final, whatever. Anyway, we will have the one exam during the final exam week. That is scheduled on the Wednesday, 6 to 8 o'clock. It's scheduled by the registrar office. So Wednesday, that will be, I think, the May 2nd. So we will have the exam. 6 to 8 o'clock. Okay. So any question? The coverage I will announce at least 2 weeks before the final exam. How much we are going to cover in the exam. Any question regarding to the schedule for the rest of the semester? And for the project, this week is the due of the implementation phase 4. I'm going to extend one more week for your implementation because we don't cover the Spark yet. So, but it's not critical for the phase 4. Okay, you can continue to implement until the final submission. Okay, I'm not going to grade the phase 4 until the final submission. So based on your final submission of the writing poster and so on, so it will be graded. So don't worry about too much the due date of the phase 4. Okay, it's just the kind of a checkup. So you will continue to work for the implement. For example, BigQuery will be discussed the April 11th. Until that time, you can study by yourself with uploaded the lab the document. I already uploaded some lab document. You can create the you can just use the existing big data, or you can upload your CSV file to the Google Storage and using the BigQuery. So it's a very simple interface that you are able to capture the contents. So don't wait until we are going to offer the exercise. Instead, you can start the study and the research on the GCP part. So anyway, that will be the April 11th. Then we will have the exam the final week. Okay. Any questions? Okay. So today as the schedule, we are going to have the presentation by the 14th team. Any distance learning student who wanna present today?
If we submitted a video already, do we still need to present?
But if you want to, if we have a time, you can. Okay. So there are 14 teams, so each team can have the 4 minutes. So it's easily longer than an hour. So I'm going to lecture first. I don't want to hurt the lecture part, so I'm going to the lecture regarding to the Spark today, maybe 1 hour or a little bit longer, then followed by the team presentation regarding to the phase 3 proposal. Team 1 first. If we start the team 1 this time, the final presentation will be in reverse. Okay, so either way. Okay, I think since it has been a while, so you probably forgot what we are doing. The quick reminder of the big data course. We are dealing with the big data. That's a problem. Okay, so if we are dealing with the small size of data, we don't have to worry about. We can use any program with a file system, or we can use the relational database model, or the other, the tool or the software. But since we are handling such a big data, there's no clear definition or the boundary of the minimum size of the big data. But roughly, we can say in the industrial solution, when we are saying the big data is several petabyte size data that cannot be handled by the traditional solution, like the relational database model can handle up to 1 or 2 petabyte size data. It works, but the bigger than that, it doesn't work very clearly. So we are dealing with such a big data. However, sometimes considering our computer capacity, we cannot handle like the terabyte size data in our company. Our company is a small, medium-sized company, so we cannot handle. So sometimes it can be the relative definition to decide what is a big data. But when we are saying the big data solution is really big data. Okay, so because of the size of the data, we cannot handle properly such a big data. So what is the solution in our previous lecture and the study and research and your project proposal? We basically divide and conquer. Okay, we are going to divide such a data. Okay, partition whatever. Then we will store such the data into the different nodes. Then using the clustering system, or sometimes it's called clustering and distributed system, so we can process such a big amount of data. Is it a new solution, new architecture? No, it has been we have been using such a distributed system, like the distributed operating system, distributed something, distributed file system we have used. But the main problem was such the traditional distributed system is not easy first. It's really not easy. So in the application level, we need to model properly, like this function works on the first node, and this function works on the second node, something like that. Or sometimes if we lose one of the data due to something failure, like the network failure or the system failure or whatever the failure, then we may lose the entire data. So that is a problem. To address such a problem, so we discuss about the Hadoop solution. So Hadoop is basically based on the two parts. One is MapReduce. Before that, we better have the HDFS. So we are going to keep the such a, that is the most of all the big data solution is based on the distributed. So we are going to distribute by along the different nodes. So Hadoop distributed, this is a file system. Okay? So we are going. There are several benefits, so I'm not going to point out again. There are several benefits of using this one. Once we distribute the big data, big file along the HDFS, so we are able to process using what? MapReduce. So MapReduce is the programming platform for the distributed file system. Okay. Then mostly it's a parallel. So basically it consists of mapper and reducer. Mapper is kind of distributor job. You are doing this one, this one, this one. Then finally we can solve the problem so by reducing the result of the mapper. So we have tested such a MapReduce programming using the Java. Plus nowadays using the other program languages, we can do that. However, still MapReduce programming is not very easy. Okay, to address such a problem, so in addition to the Hadoop core system, we have Hadoop ecosystem. The Hadoop ecosystem is based on top of HDFS and the MR, MapReduce framework, plus other components like the, for example, Hive, Pig, and Scoop, and so on. So for the programming interface, we learned about the Hive and Pig. Hive is like the SQL interface. However, even though we are using select from where whatever, it's not actually SQL inside. It will be converted to the MapReduce programming to address the problem of the difficulty of this one. Pig is a similar thing. Those who do not know even the SQL, how can we do the programming? So I need to run this one. Instead, it's based on the Pig Latin. So it's basically the data flow language. Okay, from the load the data and for each record and so on. It's a very convenient to develop such a big data solution. Actually, it's developed by the Yahoo and used a lot of that. So this is the Hadoop solution for the big data. So in the project, I asked a design model. So several problems. Some of them are very easy. The problem like the summation of the count of the patient by the state. Okay. So then that can be also addressed solved by the MapReduce programming. Then the plus think about the design, the Hive or the Pig Latin, the language. Then you can solve such a problem. Sometimes it can be the simple query, but I ask to design more the complicated model of the MapReduce or the Hive and the Pig. Then plus, today we are going to talk about another big data solution that is called the Spark. Spark is also Apache Foundation, Apache Spark. Then later, maybe a week after, we will talk about the BigQuery. This is based on the GCP, Google Cloud Computing Platform. Okay, GCP actually is not the new one. Okay, it's very similar as the existing one. Actually, behind it used some of the BigQuery, big data solution on GCP using the Hadoop. Which means when I upload the file, it will be distributed along the Hadoop distributed file system. Then when you query, it will be actually the map to the MapReduce programming automatically. But to provide the convenient interface, easy interface of the big data solution, we will talk about this one later. Today we are going to take a look at this one. So you can see the overall, the variety of the big data solution, starting from the Hadoop. Hadoop is still the top, the solution, and the many of them are actually the motivated, initiated by the such a Hadoop. So that is the reason still the understanding Hadoop is important. Plus we can use the ecosystem like this one, and many of the company use this conventional Hadoop and their ecosystem as a solution of the big data. Nowadays, the Apache Spark is highlighted and the user left, and move to the cloud solution like the Amazon, the big data solution. But this semester we will use the GCP as a big data solution, this one later. So Apache Spark. So what is the main difficulty of the MR solution, MapReduce? You already started to implement. So what is the most difficult part? I'm not very good at Java. What do I need to do? Study, right? Even though I know the little bit about Java, so key part is how to, I keep asking, model the MapReduce solution. What does that mean? Modeling the MapReduce. So if we have the big data, like this one, and plus we have the problem, counting number of the patient by the state. Then how can we do that? So we need to understand the data, then define key and value. Key and value, key and value, key and value. Eventually, then by applying the certain function, count, whatever, it will be the output, which is the output. So it's not easy. Even though I have the approach, but in terms of MR, the key value, very hard to model. Okay, you can start from the typical summation or counting or such aggregation, the model, but it can be extended to the join and the other. So please think about once you are successfully doing the ML programming for the such aggregation. Many of the students only consider aggregation, like what is the maximum, what is the count, what is the summation. Plus, think about the different model that I introduced, and also I do not introduce very detailed, but you can find the different types of the MR model here. But still, problem is it's not very simple to implement. For example, the summation or the aggregate function, or even join. Join is the more difficult to comment. You need to. Sometimes it's called hard coding. You need to do everything in your programming. So, to address that problem, it was, I think, from the UC Berkeley, right? Ali, it's from the UC Berkeley. So it's Spark.
Yeah, I think so. Yeah.
So AEMP, there might be the name of the lab. The UC Berkeley, the computer lab. They think about, is there any way to simplify the convenient way to develop using use the HDFS, distributed file system, then the more the convenient the interface or the platform rather than the MR programming. So they make the Spark. Spark is not the language. Spark is not the language itself, just like the MR is not the language. Okay? It's the platform for the distributed processing. Similarly, Spark is not the language, it's the distributed programming platform. So, using this one plus, we can use the Python. We can use the as a programming interface. We can use a Scala. Even I never used the Scala. So today we are not going to use the Scala, mostly Python as an example. Nowadays, the R programming is also the can be interface. Java, yes. There are more and more. So, but the Python is most popular programming interface, which means you can use if you know the programming or any of this, you can use your programming for the Spark. Then what is the Spark? So, what is the main problem of the dealing with such a big data? It's a big. When you have the big data, So we decide to use a distributed system, okay, to address such a problem of the big data. Then, once we distribute it, the main issue, even though we divide and conquer, so each of them, it will take a time to process. Still, this is a huge. Even though it's a scalable based on the number of nodes, okay? But it's not like the logarithm, okay? It's a scalable linearly. Linear is not the best optimized solution in terms of scalability. So, what will be the? So think about if you already took my course before operating system and database. What is the basic approach whenever we encounter the problem of the speed in considering computer science history, computer history? Memory, that means?
Performance, speed.
So how can we get such a better performance?
Registers and cache.
Register, cache. We can always use the cache. Think about the program on your hard disk drive. So because it's slow, so we put the memory. Okay, memory is the main storage, but still memory is not. It's a microsecond level, but the CPU is a nanosecond level, the speed. How can we address that problem? We can put another cache, L2 cache, layer 2 cache. L2 cache is still slow comparing to the CPU speed. We can put L1 cache also, okay? And sometimes the L3 cache is a different layer of the cache. Then, what about the database? How can we speed up the DBMS? We can put a lot of the memory size buffer, which is called the buffer area. So, similarly, when we encounter still is not good enough the speed using the MR and not very convenient way to program. So Spark provide, how can we? Just like the cache, why don't we use more memory to process the data? Okay? So bigger and bigger. So we will use the memory. However, main problem of using memory, we lose the data without power, right? It's not persistent comparing to the file system. We are using, even though the Hadoop solution usually like the bigger size of the memory. But they're processing with the data from file system, and sometimes it's cached, but basically their data are stored at the file system. Because of that, why don't we use more and more memory? So that is the idea of the Spark. But problem is, this is not persistent. Okay? If we lose the data, we cannot believe the output of such a big data solution. So we try to make the persistent the data structure that is called resilient. To make the resilient structure. So by combining this one, we Spark provide a new data structure to handle the data, which is called the RDD. Resilient, persistent, distributed data. Okay? It's a new data structure. Where? It's in the memory. Actually, the Spark use huge. That is the reason it's faster. Somebody said the Spark solution is 100 times faster than the MR, the Hadoop programming. Because of this. And they are resilient, which means it's persistent. So, mostly to understand the Spark, first you need to understand what is the RDD data structure. If anyone who learned R programming, so if you are studying R programming, it's a simple, shell, the program language, but you need to understand data frame. Okay, data, how, it looks like the two-dimensional data, how you guys understand such a data frame is important. Similarly, the data will be stored and processed in the RDD. So this is our main characteristic of the Spark. So Spark is actually somebody says nothing but the RDD. Then this RDD provide, it's the first time it was programming API level. They code and based on this one code more as the simple. Then The first generation of the Spark is 3 years ago. It was the API level, programming API. Nowadays, it's version 2 is RDD, data, the structure, the API for this one. So understanding this one is critical. So today we are going to quickly see what is the Spark and what is the RDD and the basic solution, like the hello world style, the word count. So in the using the Spark, surprisingly, it's the 3 or 4 line is enough for the word count. So we will see how it works. So this slide is prepared by the GA, the Harley, the last year. So basically, base concept is not much changed. We will see. Okay. So it's not modified. It's a new development for the new framework for the big data solution. Okay. So which means it's general purpose. It works with not only the Hadoop, but your local file system or I'd like to work the other file system, JSON file, any. So it's a general purpose. So you don't have to rely on the HDFS for the Spark. It can be worked with many other file system or source of the file, source of the data. And also later I will show you several, in addition to the core component of the Spark, there are 4 the component. One of them is streaming. So it supports very strongly the streaming data. Okay, usually the benefit of using such a Spark is a large scale the streaming. It's 100 times, but later we will see. Okay, so and it's very fast anyway. So very fast. The main thing is because of this, they're using memory and the RDD structure. Okay, it supports many other the source of the data. Okay, it started from 2009, but I think 3-4 years ago it is adapted to the Apache Foundation, the project, open source project. So nowadays it's used a lot. I said 2013. It's a donate to the Apache Software Foundation. So fast. That's the first thing, and it can be used for any types of the data analytics, especially for the big data. But not only for the big data, even just data analytics, Spark can be used. Okay, because of the characteristic, memory is caching a lot, so it's mostly happen. Which means if you set up the Spark, the server, you should have the huge size of the memory. Memory is the core part whenever you build a big data solution. A lot of the benefit I already explained. So usually it is saying that 100 times faster than the Hadoop. Okay, and it support the streaming. Okay, because of this characteristic, huge memory. Okay, so it used a huge memory size. Okay, so these are the Spark core that I explained. Then the data frame. So RDD is the main part. So you should understand. You should. So when you learn the new program language, you probably search a lot, for example, Java, Javadoc, then what kind of the API are supported, how to read the data, how to save the data, and so on. Similarly, you need to understand the data frame, the API, RDD API. On top of that, Spark streaming support is an addition. It's like the Hadoop ecosystem. The Hadoop ecosystem on top of clustering and the HDFS, the MR, we have a bunch of ecosystems. Similarly, we have such a component. These are the basic and the very popular component. One is the Spark streaming. It supports like the Twitter data. Tweet is every time how many? So a lot. It's like the streaming data. It's like the video stream, and that is strongly supported. And Spark SQL is you can use the SQL interface. Okay, for the programming of the Spark. So it's, you don't have to use at this time, for example, Python. Okay, Python. So you can directly use the Spark SQL. Then it's like the Hive. So it will be internally converted to to access the data frame data. And the GraphX is support the graph data structure. We will discuss more in the NoSQL databases such as graph data structure. Then the machine learning library. frankly speaking, I don't use the Spark, the machine learning library. So instead of Python, directly use the Python library or PyTorch and so on. But the Spark also support machine learning library. So Spark pursue the one key solution. So using only Spark, you can do the most of the such a big data. Not only the big data, based on the big data, you can do the data analytics and the AI and so on. However, if you are interested in the deep learning, deep learning is supported in the Spark. I don't think so.
I'm not sure.
Yeah, I don't think so. It's a traditional machine learning library. It's used. Then additional package. Regarding to the programming interface, you can use Python and Scala is the first two program language. But Java is added. Then nowadays R and the Moa, the program language, are supported. You can select the. I probably guess most of the students nowadays are studying the Python. If you not, please start right now. Okay, so that will be very, very helpful. Okay. Then the source of the data is general purpose. Most of the data sources are supported, including Hadoop and the HBase, but the JSON file, the traditional RDB, and the Cassandra Hive. So most of them are supported. And nowadays, the Google storage or the Amazon, the S3, the cloud, the source are also supported. We will see more details of the streaming. So, yes.
So in this case for our project, wouldn't it be better if we focus on Spark to implement our project?
Yeah, Spark. Then at the time you can use the HDFS. So right now we are using the HDFS for the data source of the Spark. So you can use the existing virtual machine. So for your project. However, if you want to implement your own, you can download the Spark and install, but you can run the Spark in the local machine. But at the time, it's a different source of the data. Okay. For example, my data source is actually the JSON file. So you can actually directly use the JSON as the source of the data. Okay. So, but if you store the JSON file to the, I think that it may be also possible. Okay. So then, what is the RDD? This is first, where is it? What is it? It's a data structure. Okay, that is the best way to understand. So this is the data structure. Data structure is not only for the database on the hard disk drive. It can be memory, it can be CPU, it can be anywhere in the computer system because computer can understand only data structured data. This is also the data structure to address such a problem. So it's in the memory. However, memory data structure mostly is volatile. You lose. If you know the address, you lose the data. So we try to make it immutable. What does that mean, immutable? Will not be changed. Okay, it's a persistent, immutable. Partition. Why partition? Because our bottom line is the distributed data. Okay, distributed data and logical collection of record. Why? Because if you remember the MR solution, we are going to first define key and value. What does it mean? Key plus V. K plus V. It's one record. So we are going to understand big data row by row, record by record. Most of data we understand as a record by record. So such a collection of record will be data frame, that is the RDD. So this is the RDD. So it can be one of the interesting characteristics of this data structure is the RDD transform to the another RDD. We will see a lot later. Okay? That is for the transformation of the RDD. So these are the, you don't have to worry about right now, these are the operation method of the RDD, which means that if you remember, the second generation is this one. Data source, data frame API. So Spark means mostly is API. Then the plus data source API to set up, to get the data. But mostly your Spark, when you are saying I know the Spark programming, that means using this one of the programming, you can use such a data frame API. At the time, think about I have the set of data here. I can do pick up there is operation in terms of object-oriented concept. There is a method to pick up highest maximum value. That is one of the operation here. Okay, and I'd like to map. This is a bunch of the data. I'd like to map by record something. I'd like to pick up something. I'd like to sort the data. Okay, such an operation are here. Sometimes we can join, we can group by, you can, from the name of the such operation, you can easily understand. Okay, intuitively you can understand. Sometimes the operation, parallel operation, reduce part, collect. Usually the difference between the transformation and parallel operation is output of the operation IDD. So mostly the Spark programming, Spark implementation is IDD by applying the operation, IDD, finally something value. Okay, so these are the parallel operation like the count, collect, reduce, save, the lookup key. So mostly you are able to implement such a thing in your ML programming. So reduce part, but it's already API level. So you can just pick up proper the operation API. Okay. This is a fault tolerance, which means it's a resilient, it's immutable. You can't actually recover, even though you miss. We will see a little bit more details. Okay. It's a consistency. It provides a consistency of the data. Okay, and inexpensive fault tolerance means while we are doing such the transform and the Spark processing, we can go back. Actually, go back to recover. So that's called the log lineage, but we will see a little bit about that. Okay, it's a partition because it's based on the distributed file. Okay, and so on. Okay, this is the comparison. Somebody may be curious. What is difference from the distributed, the shared memory itself? Do we need to consider new data structure for this? This is the difference. Okay, so. For example, the writing, when you write, there is a transformation. Rather than the fine-grained means it's a guaranteed, consistent. Okay, and it's a consistency. It's a immutable. That is one of the main characteristics, and so on. So I'm going to skip this one. Then we will start. Okay, this one. So, if you do not know what is Scala, don't worry. So we are not going to use the Scala, but if anyone who ever used the Scala programming, even I'm not. I never. So Scala was actually written just like the MapReduce programming, where the Hadoop is based on the Java. It's based on the Scala, but I never used it. So even though our lecture, the material introduced both Python and Scala, I'm going to use only the Python part. Okay. And Spark also provides the shell, but that will be combined with the programming interface like the Python or the Scala. We will use the Python. And our exercise is also based on the Python. Okay. So you will see after you install the Spark, based on the Python, you will PySpark. Then this looks like the same as the vanilla interface, that is the Python interface. Like this one, but also if you are familiar with the Jupyter, so you can use the Jupyter also, like the number here, so it doesn't matter. And always Spark started, so it's from the Python interface, so you can start the SC. So SC is the Spark context. You can understand Spark context as like the Java virtual machine. It has everything, the operation. It's like the module. It will be loaded into the memory. So if you are familiar with the Python, you can import several existing packages. What happens when you import? It will be loaded into the memory. It's the same thing. Any Spark related API or such a thing will be, that is starting from the Spark contest. So you can always start with the Spark contest. That is the SC. So for example, if you want to know the application name, the sc.app name and so on. So Spark contest automatically. So when you are using the Spark, it will be start from the Spark contest or SC. Even the Scala, even though we do not know much about the Scala, it's a SC also. Okay. Then first thing always when you learn the Spark, so it's a start with the IDD. So resilient means it's even though it's in the memory, we will not lose the consistency. Okay, it's immutable. It's not changing. That is the important part. Then we can rely on using the memory. Then the distributed, and also this is the data set. So it's a memory in the data set. It's a memory data set, it's a memory structure, but it's a resilient, so immutable. That is the idea of the IDD. So you should be able to use such an IDD to get the data, to get the change the data. How? Using the operation, mostly API level. So you should know I'm going to introduce some basic operation, but you should be able to use such operation. Okay. So IDD is really basic and the first step to understand the Spark, to learn the Spark. Okay. Okay. There are different ways to create the IDD. Okay. First, I have a data in the file. Then you can create the IDD from the file. Or so. My data is already being processing is in the memory. You can create the IDD from the data in the memory. Like it's a Python, the list file. Then from that, you can create the IDD. Okay. And also another IDD is most popular. Once we load the IDD, once we have the IDD, then we need to process the data. How can we process? Using operation method. Then it will create there are two. The operation one is the transformation. So transformation create another IDD. It's the most popular. We will see the example here. So this is a file-based IDD, which means we are going to create the IDD memory structure from a file. This is a file, local file. It can be HDFS file. It can be other file system file. Any file you can specify. Default is the default. The file system, file source of the Spark. Okay, you can specify the default. Mostly, if you do not specify, it is a local file. So, in case your virtual machine, it will be HDFS. In case of I download the Spark and install under my Windows machine, then the Windows file system will be your default local file system is the default. Anyway, then as you can see, it's the SC dot because SC is the everything of your Spark. So automatically, always you need to use this one. Text file is the probably API operation to read the data from a file. That is the file, and local file has this one. Then will be stored at my data. Okay? At that time, IDD my data will be created. Where is it? It's in the memory. Okay? Right now, it's loaded into the memory and like this one. Then, you can see the line. Here, why? So, you remember, the IDD is record by, record automatically. So this one, even though there's new line character does not mean it's a record, but we are going to use such the new line character as a separation of the record. So each one will be record. Okay, so this is one of the very simple example to create the IDD. In this case, it's from the local file. Okay, then what about the operation? What kind of? There are two types of the operation. One is the return value. For example, how many record? Count. Count the output of such operation will be one value. So that is the values. The return of that operation sometimes is a value. That is called the action operation. It's action. However, as I introduced, some of the operation is from one RDD to another RDD. Okay? So it's a transformation. from this slide, whenever you see the arrow, this means it's the action. Okay? And whenever you see this arrow, this is like the triangle. This is the arrow. This means it's a transformation, which means from the base RDD and the new RDD will be created. What about the count? Here, count is the action or the transformation? It's the action, because output will be number of record, one value. So you can easily. So right now, since you don't use you never use this one, but once you can use it, it's not a big deal to understand. Some common action, which means some very basic operation that produce the value. So like the count, you already know. Take n means top n record. Top n record. So return an array. Sometimes you can understand that it's an array of the record. Okay? So from the top n, take 2 means first 2 record will be returned. That is the value. Okay? Not the RDD. Collect all of them and save as text file. Okay? So it's a reverse way. Reverse. So you wanna save because the RDD anyway is in the memory. So I wanna keep such an output, the RDD to the file at the time you can use such a. These are the common action. So whenever you see the yellow, the background, the box, that means it's a Python. Okay, so you can pay attention to the yellow box for the example of this one, like the count. And for example, you can simply understand 4 line in my data take 2. Have you ever seen this kind of the syntax? It's from Python. Okay, so Python, the for loop. So from my data that take 2 is the 2 value array, right? So 2 value. So for each value can be the line print 1 by 1. So I never hope to see one. Okay, this is a Python code. So Spark uses such a programming interface from one of them. So if you understand the Python, so we are going to use this one. Okay. And the example of the transformation, like anyway, RDD is immutable, which means it's not changed. So, which means you cannot change I have RDD here. So I try to change M to N. No, you cannot do that. Always you need to create another RDD. That's the reason. If you remember, we can always recover. How? Because we do not change the data. After transformation, we can go back because it's never been changed. So that's the reason we can go back and recover the data in case of something, the missing or something happened. Okay, so this is a transformation. What kind of transformation? Common thing is a map. Map means we try to create a new one by performing inside the function. So this is very important when you when you learn the Spark. So have you ever heard about the functional programming? Functional programming? Any program language. In any program language. Java support the functional program language. So from Java 8. Frankly speaking, I never tried the Java, but other programming languages. So what is a functional programming? It's kind of anonymous between the function. So for example, I try to calculate the GPA. So you need to create a function to calculate the GPA as an input of a student ID and calculate and return the value. So this is a function. So to use this one, you can call the GPA. Okay? Then do whatever. For each student, if you have the student list, okay, you can do that. However, if you want, instead of creating the function, you can put the block of the calculated GPA inside this one directly. So you, instead of specify, you can do that. You can do the traditional programming, like the creating the function, then the use the function name here. Instead, the functional programming is anonymous, which means directly this part is included as an input parameter. Okay? Then you can simplify the programming a lot. Actually, the one of the main difficulty of the programming, you need to design this function, this function, this function, call this function, and so on. He said, can I directly use that such a function? Some of the function is very simple, return name. Okay? Or just the change uppercase, lowercase. Do I need to create separate the function? Sometimes it's tedious. So instead, we will use directly such a logic of the function. It's an anonymous function. We do not create such a thing. Instead, directly use it. We will see such an example. So in case of Python, how can you do the functional programming? Lambda. We can use lambda. So if you are not if you never use the functional programming, I think that's kind of trend of the programming. So please, this time, try to use. It's not very complicated once you get used. The map is using for example, we have the IDD here for each record. So we can apply the uppercase. So we can change uppercase, all uppercase, each record. That is a mapping by applying the function. Okay, so this is a very, very typical approach for the Spark program. We will see more in here. Filter, as you can imagine, by applying the function, if the GPA is high, the ID is higher than 1,000, then do something. So you can do such a filtering part. So filter is another popular one. So let's take a look at the mapper and filter transformation. Here, this is what? IDD. This is the original IDD. Then, take a look at this one. Map is the map operation. Inside, lambda means it's a functional programming. Okay? And for each line dot upper, we are going to change each line as an upper class. Directly apply. So, actually this should be what? Parameter. Okay? Input parameter. But instead of input parameter, we directly apply such a block of function inside. For each line of this, then apply this. Then it's not complete code. Somebody may be curious. So how do I know that this one? Actually, this IDD is named .map. Like that. We will see such an example on next slide. And after changing the upper class, is what? Transformation. It's also IDD. And filter, lambda line that start with I. What does that mean? This is the built-in function. It's a Python function. Then only record start with I. This one yes, this one yes, this one is no, this one is yes. So 3 records will be returned. What is this? It's also IDD. So the typical Spark programming is like such a functional programming using operation. Okay? So let's take a look at this one. Is the example of yes. This is an example of Scala, right? But it doesn't matter. Let's see this example to explain. So, start from the local file and load. This one is loading to the IDD, and we apply the map operation with this function, functional programming, uppercase, then the filter, and this one. However, as you can see, this is a blank, all blank. This one, we expect the change of the data. However, all of them are blank. Then, when we learn the action operation, is a field. It's a really important concept of the spark to speed up. What does that mean? This operation will not be running. Will not be running until action. Which means once action is the run, then record by record, if you understand, it's not exactly the same. If you know the pipe in operating system, what is a pipe operation? One of the input, output will be input of another. It's kind of streaming, piping. Okay? And instead of storing the data, we can directly send to. So we can speed up and simplify. So same thing. We do not run the each and every time. Instead, once action is run, record by record, it will be operating, running. That is called the lineage characteristic of the IDD. So IDD actually, so do not run the each transformation action, transformation operation until, but after the action operation, it will be run the kind of stream, piping the operation. So per record, okay? So this is the very important concept. So sometimes you may not get the error message even though it's not existing. Why? It's not running until the action, okay? So that is a kind of a change, okay? Oh, you can change the command like this, dot chaining the method. So you probably know that this kind of method instead of multiply. If you see this one, then the easier to understand such a lineage characteristic of the IDD, right? So same thing in the Python. So then it can be reversible because of this characteristic. So that is the to debug string. I say in the Scala Python. To debug, you can actually go back and go back and go back to the debug. Any malfunction or something unexpected data, you can do that. So using the to debug the string. So this is a pipelining of the characteristic. Okay. So functional programming, as you can see, is very important to understand. I don't want to use such a functional program. Yes, you can do that. However, it will be very complicated program in data analytics. The main part of the Spark is the data analytics. Most of the functional programming is not huge logic. Okay, it's very simple, so you can simplify the program, Spark program. So like this one, you can implement such a way. Instead, you can directly use the inside. So Python starts with always the lambda. So for the functional programming, so if you want to know about the more details of such a functional programming in each program, you can find the reference or the document from for example, Python. You can find the Scala, the Java from the version 8 is support, but I never use. Anyone who tried? Last year, there were a few students. Okay. So you can directly use such a function like upper and so on. So please try to use the functional programming in your project also. Okay, so these are the key part of the IDD. So this one is the most important part. So we will see the more example about IDD later. Okay. And as you have seen, there is a lazy execution, and there is a Spark used a lot. There's such a functional program. Okay. Let me introduce one more. So I decided to explain the IDD. So this is how to create IDD. Another example of the creating IDD is from the memory data. Okay, so for example, this is the Python, the array list. So we have the 4 of them. So we can create the IDD from the Python object, like this one. Okay, the parallelize, we can use the parallelize, the operation. This one is only good for the testing purpose, or the small size of data. Because anyway, the data source should be stored at the memory. But it probably limited, right? So it can be used for the testing purpose by typing directly, or sometimes the small amount of data loaded into the memory processing and creating the IDD. Okay, and from the file I already explained, but you can see what about the multiple file? You can use the asterisk, so like that, or the comma, then you can upload the multiple file. But if it is in the different source of the data, so like you can use this one or this one, so I can do that. So finally we can create then the input and output format of such a IDD. Have you ever seen this kind of thing? In the MapReduce programming, we use this one, text input format, text output format. It's separated by the new line character, and or the sequence. So actually, the Spark is based on the header of the MapReduce program. They are using the same classes, Java classes. Okay, so you can use the same the input and output format. That is in the SC always the Spark context. So for example, this is the file-based IDD. Oops. This is a file-based ID. What about the file? In this case, it's a JSON file. Sometimes you should upload. You should create the IDD from the many small-sized file, millions of the JSON file. Okay. At that time, you can use such a whole directory. So you can put the whole file to the directory, then create. And inside, after the IDD is created, it's like this one. Okay. So then you can see the JSON file, and it has all the attribute and value. Attribute and value will be like this. So this one will be used for the directory. Will be used for a lot of small sized file, like the JSON file. And you can specify my directory. Why don't you try to understand the meaning of this Python code for the Spark? So we upload the whole file in the my directory, and that is the my IDD1, and the IDD1.map is a chained method. The map operation, then by applying the JSON that load the JSON file. Okay, it's a file length. Okay, then not file length, F name. So if you see the JSON file, the F name is the first one, first name. The first name will be the string. So that string will be stored. So we can take the first two. That is the first name of the file. There's Fred and Barney and so on. So it's a different IDD operation. So flat map and the distinct and the sort by. Flat map is if you remember the mapper from the file line of the file, we divide, like the word count, divide by the space. Then we have a number of the word. Similarly, flat, the map is the one element, which means it map usually the one record of the data into multiple elements. If you chop by the word and so on. Distinct, remove, duplicate data. And the sort by something, order. And the multi-IDD invite multiple IDD, like the join. So for example, join, there's a join, but it's not here. The intersection, the common, the data will be returned. Union, combine. And the zip is the zipper, like the combine. The 10 record combine into the one IDD with the 10 record. So for example,
Is it like normalization, Professor?
it's not normalization. I will show you the example. So here, so this is the flat example. So split by the default split is the blank. So I never seen a purple like this. Okay. Probably you are familiar with this one. Is from word count. Okay, split by the space. And then this one is what happened? This thing. So duplicate that will be removed. Zip is here. If you zip the two RDD, just the first record will be combined. Okay? And the second Boston and Boston will be combined. Paris, the Amsterdam combined. It's not normalization, just zip. With subtract, you can minus. You can make it in, not in, and so on. Union, combine the both of them. Then there are more RDD operations, so you should be familiar with the more and more RDD operation. The first, you can easily guess, is the first top one, and for each, and top end, and sampling, and take the sample. Okay, so I'm going to start today's lecture for the Spark here. So we will have the 10-minute break, but the next class, the